Okay, so this is the key to the worksheet section 2.2 part 2, and they want you to determine whether each statement is true or false. So the word Baton Rouge is an element of this set. Yes or no? So is this um, word an element of this? Yeah, because you see it. So that's true. Okay, now be careful with some of these are a little tricky. Okay, so remember this symbol means an element of, this symbol means a subset of. So first of all, is this listed as a set or an element? It's listed as an element, right? This is listed as an element, not a set. Okay? So since it's listed an element, then that's going to be a false statement because Baton Rouge is an element of, it's not a subset of. Okay? The way it's listed is an element. So that's false. Now compare that with this. Now this is listed as a subset. So here's the question. Is this set a subset of this set? Yes, because it's listed in here. Okay? All right, so that's true. All right? Okay, now let's look at part D. All right, so is the empty set an element of this set? Remember, an empty set is an element of, an empty set is a subset of every set. So is an empty set an element in here? No, you don't see it, right? So you don't see the empty set here. So that's going to be false. Because remember, this is listed as a set. That's a set, the empty set. Okay. Now here, is the empty set a subset of this? Yes, because remember the empty set is a subset of every set. The empty set is a subset of every set. All right, so yes, the empty set would be in there. So that's true. So these are tricky. You got to look at the symbol here. This is an element. This is a subset. So the empty set's a subset, but the empty set's not listed in here. It's not an element. Okay, F, is 6 an element of here? Do you see 6 in here? Yes. Now be careful. Is the element 6 a subset of this? No, because remember this right here is subset. First of all, is this listed as a set? No, it's listed as an element. This is listed as an element. Okay, so that's going to be false. All right, now if I had this, now remember, if it said this, if it said that, so is this set a subset of this? Yes, it is. Okay, because you see 6 in here. Okay. 2. Is the set 2, 3, 4 not contained in this set? That's a false statement because it is contained in that set. Is the set 5, 6? Now this, remember, this is subset, this is proper subset. Is 5, 6 not a proper subset of 6, 5? That's a true statement. All right, now be careful. It said this. See, you got to look at this. So is this set a proper, this means proper, proper subset. Is this set a proper subset of this set? No, because they're equal. So then let's answer this. Is this set then not a proper subset of this? That's a true statement. Okay. All right. Now let's list all the subsets of this. So remember the subsets. Remember when we talked about here, the empty set's a subset of every set, right? So that's the idea here. So when I list all the subsets, I'm going to have the empty set, I'm going to have the element with just A in it. I'm going to have the element, the set with just B in it. I'm going to have the set consisting of just C. I'm going to have the set consisting of the elements A and B. I'm going to have the set consisting of AC, and then I'm going to have the set consisting of BC. All right. So that's 1, 2, 3, 4, 5, 6, 7. So this right here has 7 subsets. All right. Oops, I'm sorry. 8 subsets. What am I missing? I'm missing, remember, every set's a subset of itself. Okay, 3. Calculate the number of distinct subsets and the number of distinct proper subsets. So remember the formula for the number of distinct subsets, remember that's going to be 2 to the n, right? And the number of distinct proper subsets is always 2 to the n minus 1. So this set consists of 4 elements. So the number of distinct subsets will be 2 to the 4th, which is 16. Just like here, if we did this, that would be 2 to the 3rd, which is 8, and that's what we said, 8 subsets. So the distinct subsets, remember, so these are all subsets. These right here, this all the way to this, those will be proper subsets of this. So is this a proper subset of this? Yes. Is this a proper subset of this? Yes, and so on. Not this, because those are equal. All right. So they're equal. They can't be proper subsets. So that's why we take away 1. So if I took this one away, that would leave me with 7, and that would be 7 proper subsets. So that would be 15. Okay, here, the set of x's such that x is a month beginning with the letter J or M. So first of all, let's determine which months begin with J. So there's January, June, and July, right? Let's talk about M. For M, there's March and May. So if I look at that set, how many elements are in that set? What's the cardinal number? 1, 2, 3, 4, 5. So there's 5. So in here is 5. In here is 4. So this is going to be 2 to the 5th power, and just use your calculator. 2 to the 5th power is 32. And so the proper subsets, you just take away, if you were to list all the subsets, there'll be 32 of them. You take this one away, and that'll leave you at 31. So it'll be the number of proper subsets. Okay, over here, let's see, 1, 2, 3, 4, 5. Oops, I think I did. Let me do this one again. So 2 to the 5th. So that's 2 times 2 times 2 times 2 times 2, right? 1, 2, 3, 4, 5. So that's 4. That's 4. 4 times 2. Yeah, that's right. Okay, 32. All right. Okay, so let's look at this one. So here I have the set of natural numbers, and the natural numbers between 4 and 9. So here's my set, 5. See, there's no equal sign, so you say 5, 6, 7, and 8. So what's in here? N is 4. So there's going to be 2 to the 4th, which we already figured out. That's 16. And then this will be 15. All right. Okay, here, if I list my elements, that will be 4. Notice the equal signs in both of them. 4, 5, 6, 7, 8, and 9. So that's 1, 2, 3, 4, 5, 6. So n is 6. So this will be 2 to the 6. If you use your calculator, that's 64. And then this will be 2 to the 6 minus 1. So it'll be 63. So it'll be 63 proper subsets. Okay, so that's going to take care of the key to section 2.2, part 2.